Section 3.6 is about graphing inequalities. Just to for us to have an idea, this is basically what we're going to finish with. Uh, if you guys notice, we have a line. Sometimes it's a solid line, sometimes it's a dotted line, and then some shading. What that really means is that I remember back in section 3.2, we learned what a solution was. Now we'll come over and then I will give you guys, back then it was just an equation, like y equals 3x plus 5. And then I will ask you guys, is 0, 2 a solution? And then you guys will figure out whether it was yes or no. You guys will substitute the values of x and y in there, and then you guys will tell me yes, it is a solution, or no, it's not a solution. In this case, it is not a solution, but that's basically what we learned back in the days. Now, with inequalities, we're going to be doing the exact same thing, but for inequalities, we don't only have a solution a part of a line. We could have a solution off the line. So that's what the shading part means. Any point in the shaded section, it's a solution to the inequality. So on equations, we were restricted to a line only, but now for inequalities, we can deal with the line, but then we also have points that are not on the line. So once again, that's exactly why we're going to be shading stuff. It might seem complicated to begin with, but it truly is not. If you know how to draw lines, it truly is not. So first thing you guys are going to start with, state if 4, negative 3 is a solution to the following inequality. Looking at the first one, y is less than 3/5 x plus 2. Instead of y, I'm going to write negative 3, and I'm going to go 3/5 times 4 plus 2. My question is this true or not? So I have negative 3 is less than 12/5 plus 2. My 2, I'm going to change it to a fraction with a 5 at the bottom. And for me to know what the top is, since the whole thing is 2, I'm going 2 times 5 is 10. So I have that negative 3 is less than 22 over 5. Now this is a true statement, so I'm going to say yes. Yes, it is. If it had in the inequality sign, if it had the little line at the bottom, less than or equal to, remember, in order for this to be true, one of the statements has to be true. It's either less than or it's equal to. So even if it had the inequality sign in this case, it will still be true. Those two are not the same, right? 22 divided by 5 is not negative 3. So they're not the same, but negative 3 is still less than 22 over 5. So this is what you guys are going to be doing. Let me do one more, my example 2. Instead of y, let me write negative 3. It says is greater than 4 times 4 minus 1. So I have that negative 3 is greater than 16 minus 1. Negative 3 is greater than 15. Right? Negative 3 is not greater than 15. That is not a true statement. So I will say no, that is not a solution to this inequality. So once again, the first part is just kind of like how we did before. Substitute the values of x and y and tell me if the statement is a true statement or not. Now, moving along to learn how to graph them, first of all, let's talk about the lines. If we talked about some lines being solid, so for me to have a solid line, and we also talked about some lines being dotted, the solid lines, we're going to have it when our inequality sign has that little line at the bottom. So I'm looking at less than or equal to, greater or equal to. Whenever it has the little line at the bottom, my line will be solid. And the reason why, because the line is included as part of the solutions. So once again, if it has the little line at the bottom, my line will be solid. Now it will be a dotted line if my inequalities, it's either this one or this one. My inequalities do not have the little line at the bottom. What that means, the line is not part of the solutions, right? Any point on the line, in this case, would not give me a true statement. And so we're going to get to see that in a minute. Now, for the shading, because we know sometimes we shade it above the line, sometimes we shade it below the line. So let's take a look. Sometimes we're going to shade above the line. Sometimes we're going to shade below the line. Now, for us to be shading above the line, the y value has to be greater than the other part. So I'm gonna have something like y is greater than, or something like y is greater or equal to. Like whenever my y is greater, and then on the right side, I could have anything that I want. I could have like 3x plus 5, for example. As long as y is greater than, or y is greater than or equal to, once again, as soon as y is greater than, that part is included, I'm going to shade above the line. Now, if y is less than, or y is less than or equal to, as soon as y is less than part of my inequality, I'm going to shade below the line. All right, so now that we have that, let's take a look at a few examples. We know how to graph lines, especially if it's given in slope-intercept form. I'm going to think of this as a line to begin with. So I know my y-intercept is 0, 5, right? Looking at this, positive 5, I know my y-intercept is the point 0, 5. So I'm going to do that point. My slope is a negative 2 over 3. We talked about this before, that if there's a negative sign, either give it to the top or give it to the bottom. In my case, I'm going to give it the negative sign to the top. So this thing says go down 2 and 3 to the right. So down 2 and 3 to the right. And then I'm just going to connect my points, right? We learned how to graph points. We learned how to connect them. Looking at my inequality side, notice how it's just greater than, not greater than or equal to, it's just greater than. That means my line is going to be dotted. Then I'm just going to do the best that I can, something about there. So it's going to be a dotted line. Once again, any point on the line does not give me a true statement. Now I'm going to shade either above or below. Notice how y is greater. So I'm going to shade above the line, which means this area. Any point in the shaded area, it's a solution. Any point. The line is not included, so just the shaded area. Any point there, if we substitute it for values of x and y, will give us a true statement. Any point outside of the shaded area, so any point here, will not give us a true statement. Okay. I'm not gonna come and say it has to be well shaded. As long as you give an idea which section did you shade. That's basically what we're looking for. Looking at here, sketch the graph of each inequality. Notice how this is not given to us in slope-intercept form. I have right now x minus y is less than or equal to negative 4. It's nice when the y is by itself, so that's exactly what I'm going to do. I'm going to move the x over as a minus x. So I have that negative y is less than or equal to negative x minus 4. I'm going to divide everything by a negative 1. Remember when we used to do inequalities, and every time we divided by a negative, we have to flip the inequality sign? That's actually going to stay in place. So I know my sign is going to flip, so I'm going to have y is greater or equal to positive x plus 4. Okay, so I know my slope, my intercept is the point 0, 4. So that gives me that point. So about there. All right, so 0, 4 is my point. My slope, remember, I see a 1 in front of the x, but I do like it as a fraction. So let me put another 1 at the bottom. So my slope is 1 over 1, which says from the point, go up 1 over 1. My inequality in this case is going to be a solid line. And once again, I'm going solid because notice how on my inequality sign I have that little line at the bottom. So that's why it's solid. Notice how now here to my answer, my slope-intercept forming at the end, y is greater than. So I have to shade above the line. Sometimes it might be a little bit hard. What's above, what's below, where do I shade? Now looking at that, follow the y-intercept. So looking at here, I know I have to shade above. So above means to go up. If I move my cursor up a little, you guys see I'm shading this side. So once again, any point over here is going to give me a solution. Now, let me erase this real quick. There's going to be a couple cases, the special cases. I like to deal with special cases. So let me use this graph. Let me block that over. Our special case, it's when we have the x or the y by itself. Let's say, for example, I had y is less than 5. We know that y equals 5. The y equals 5 looks like the x-axis going through 5. In this case, I'm going to use a dotted line because my inequality does not have the or equal to part. So I'm going to use the dotted line. And because the y is less than, I'm going to shade below my line. So I'm going to shade that. The y by itself is not too complicated. Now, the one that it's a little bit hard, the one that we might have a little hard time dealing with is when the x is by itself. So let me take a look at an example of that one. Let's say I do x is greater or equal to, so I want to do a solid line this time. X is greater or equal to, let's choose positive 2. I know that x equals 2 looks like a vertical line going through the 2. So let me do that line. That's my x equals 2 line, right? I did my line. Now on the shading, x is greater than, above the line. I'm going to deal with positive, to the right of this line. So in this case, when the x is by itself, when x is greater, I'm going to shade the right. I know once again with the y was by itself, above and below was easy to see, above and below. But now the x, there's no above and below. When the x is by itself, when x is greater than, I'm going to shade the right. When x is less than, I'm going to shade the left. All right, once again, any point on the shaded section will give me a solution. So good luck on your homework.